Hey guys, today I'm here to review empirical and molecular formulas. So we're going to start with a couple empirical formula practice problems, and I'm going to do the first two on this worksheet. So we're do 1 and 2. So on this sheet, we're going to determine the empirical formula of each compound from its percentage composition by weight. So the way we're going to do that is, let's start with problem 1, where we have 66.4% copper and 33.6% sulfur. So you might be wondering, how are we going to find the empirical formula? Now, step 1 is we're going to have to convert this to grams. So the easiest way to do this would just be to do this out of 100 grams, so that we can just simply convert the numbers from percentages to grams without doing any math. 66.4 grams copper and 33.6 grams of sulfur. So now that we have that in grams, now we need to convert these numbers into moles. So let's start with copper. We have 66.4 grams of copper multiplied by the molar ratio. So we're going to do 1 mole of copper over the molar mass, which for copper, again, we're going to want to use exact values, is about 63.546 grams. Just make it a fraction bar here, so it's a little easier. And this will give us the value in moles. Now let's set up our second equation. So for sulfur, we have 33.6 grams of sulfur. And we're going to want to multiply that by sulfur's molar ratio, or molar mass ratio. So we get 1 mole of, I wrote copper, 1 mole of sulfur over the molar mass, which is, hold on 1 second, approximately 32.065 grams. So if we use our trusty calculator, we can just quickly do the math on this. And for the first equation, we get approximately 1.04. Approximately 1.04 mole of copper. And for the second one, we get approximately 1.05 moles of copper. Or sulfur, sorry. Moles of sulfur. So now that we're done with that, hold on, I need to write sulfur. Now we will divide all of our both of the elements, moles, by the smallest value. So what we're going to want to do is we're going to want to take 1.04, drag it on over here, if I can do that. Yes. And take this over here. And we're going to want to divide it by the smaller value, which in this circumstance is going to be the 1.04 moles. 0.04. And we're going to want to do the same for this one. We're going to want to divide it by the smaller one. And obviously for the top, we just get 1. And for the bottom, we're allowed to approximate that to 1. So since we got 1 for both, it's just going to mean that these are going to be our subscripts, which means that our subscripts are going to be for copper, it's going to be 1, and for sulfur, it's also going to be 1. So that is the end of problem 1. For problem 2, we're going to do a similar process. So I'm going to quickly clear the frame. Okay. So for problem 2, we have 79.8% copper and 20.2% of sulfur. So remember, the first thing we're going to do is just convert it to grams, which if we do out of 100 grams, we don't have to actually change the values. And there we go. Now, now that we have the values in grams, we do the same thing. We're going to convert everything to moles. So we're just going to multiply the amount of copper by its molar mass. So we get 1 copper over we have it here 63.6, and we can do the same for sulfur. So we have 20.2 grams of sulfur multiplied by 1 mole of sulfur over 32.065. And so if we do the math with our calculator, the first we're going to get, hold on, I think 1.8 divided by 63.546. You get about 1.26. And for our second one, and again, these are all approximations. There's just no approximation symbol. Typing a keyboard. Now for the bottom one, we get about 0.63. And so now we're going to want to take these values and divide them by the smallest, which essentially means we're going to divide it by 0.6 moles. And what do we get? For the bottom one, we're obviously just going to get 1. And for the top one, we're going to just get 2. Yes, get 2. And so our subscripts are going to be copper with 2 and sulfur with just 1. So that is how we find empirical formulas. We can also do one of these problems where we actually start in grams instead of percent. So let's go with, let's do number 4. So we have 87.3 grams of sodium, 121.5 grams of sulfur, and 91.2 grams of oxygen. So what we're going to do is the exact same process. We don't even need to convert to grams. We're just going to go straight to moles. Sodium multiplied by 1 mole of sodium over sodium's molar mass, which is 22 point, we'll round to 9. Next for sulfur, we have 1.5 sulfur multiplied by 1 mole of sulfur over 32.06 grams of sulfur. And lastly, we just have 91.2 grams oxygen multiplied by 1 mole oxygen over 16 grams of oxygen. So again, we're just using the molar masses that are present in the periodic table. And so now we just have some calculator work to do. And for this first one, we get 3.8. Actually, I should put an equal sign there. Yeah. For the second one, we get about 3.79. About the same number, actually. And for the third one, we get 2 divided by 16, which is exactly 5.7. And so again, we're just going to move these values over. And we're going to divide them all by the smallest one. And for this one, we can just approximate. We get 1. For this one, it's also 1. And for 5.7, we get, 1.5. And since we don't have whole numbers, this is a problem. So how are we going to solve this problem? Very simple. Since we have 1.5, which is our only decimal that we have to deal with here, we just have to multiply that by 2, because that will result in 3, which will give us a whole number. But of course, we can't just multiply 1 by 2, we have to multiply them all by 2. And so now we have our subscripts. Sodium 2, sulfur 2, and oxygen 3. So there you go. Now for slide 3, we can do a molecular formula problem. So we essentially use a similar process. Once we have the empirical formula, we are able to find the molecular formula if we are provided the molecular weight. So let's look at problem 1. Our empirical formula is NaS2O3. And our weight is 270.4 grams. That is our molecular weight. So you might be wondering, how do we find the molecular formula from this? First off, we need to find the full total molecular mass or molar mass of the empirical formula, which we will be able to do by just simply adding. So we'll do 22.99 plus 2 times 32.5 plus 3 times 60. And if you're confused on where I got these numbers, it's very simply the molar mass of sodium plus 2 times the molar mass of sulfur plus 3 times the molar mass of oxygen. And so that number, which again we can just plug into our calculator, yields 135.12. So we can just and now, very simply, if we want to find the multiplier that we need to go from empirical to molecular, you just take the molecular weight and divide it by the molar mass. So we're going to divide these numbers. And that yields us about 2. So what do you do with this 2, you might ask? Essentially, this is going to act as our multiplier. And we're just going to multiply all of the subscripts in the empirical formula to create the molecular formula. We can now just multiply the subscripts. So if we write, instead of sodium, we have sodium 2. Instead of sulfur 2, we have sulfur 4. And instead of oxygen 3, we have oxygen 6. And this is how we go from empirical to molecular formula. Let's go with one more practice problem. We can try problem 2. So with an empirical formula of C3H2Cl, I'm just going to use big numbers for now, with the molar weight of 147.2. So again, we're going to find the molar mass of our compound here, which is going to be 3 times 12.01 plus 2 times 1.08 plus 35.5. I'm just going to expand this really quickly. And this will give us our molar mass of the empirical formula, which is about 73.5. And so now we take this value here, divide it by this value here, and that will give us our multiplier. And that gives us about 2. Actually, exactly 2. And so now we just multiply all our subscripts by 2. And so you take these subscripts and you get C6H4Cl2.